So now we will start to analyze the malware using IdaPro. So IdaPro stands for Interactive Disassembler. This is a disassembler tool that which generates assembly language source code from machine executable code. So it supports a variety of executable formats for different processors and operating systems. So it supports Windows PE, Mac OS, Mac O, and Linux Elf executable. Um, so it has also a decompiler plugin for programs compiled with C and C++. But this one doesn't come free. There is a free version of IdaPro, which is only a disassembler, which just converts the binary machine code to assembler to assembly language. But the paid one, um, which includes a disassembler, is would cost an extra when you buy an IdaPro license. So we're going to open IdaPro now, and we'll just drag and drop our malware sample here. So it starts to ask the file was linked with a debug information, and the symbol file name is this path over here, which is quite long. I won't bother saying it. And it asks, do you want to look for this file at a specified path and the Microsoft symbol server? Of course, no. So it's loading now. Oh, that's pretty quick. So yeah, so the first thing I'm going to do is just browse over this function here, this functions window here. Uh, actually when the executable has been loaded to IdaPro, it it right away shows you the main of the program, which is the main function of the program. So that's really good actually. But I wanted to check first the functions here in the sidebar, just to feel, just to be, just to have an idea of what this what's the structure of this program. And yeah, after browsing it, it's there are 94 functions here, which is not that bad. It's actually a very small um, number of functions, and some of these are actually a standard library um, C++ functions, which is built in by the compiler. So when the compiler compiles this program, this one are this functions are generated with a compiler. So that's this malware is not that big. So the next step I'm going to do is check for the APIs in this import table. So these are the functions that the malware has imported from various libraries like kernel32 library, um, add advapi32, um, shell32, user32, wininet, and url1. So just I'm just going to sort it by the library name, and you can see here some registry calls, registry API calls, which is reg set value exa, reg close key, and reg open key exw. So this one looks like a persistence mechanism. It's used by for the persistence mechanism. So I'm just going to click this API here. I just want to check the cross references for this API call. So we can see here, and in this side uh, comment here, you can actually right click on that and just click list cross references to, or control X. So by doing this, you will be able to see what functions, what part of the code is calling this API. So I'm just going to click this cross references, and there are three API calls for reg set value exa. So let's check this first one. Okay. So this part here is the bird's eye view of the function for the function block. So this one is a function block. Each one of these are function block here. So let's just had a quick glance of what this function does. So it opens this registry hive software Microsoft Windows current version. Just oops, there we go. So it opens this registry hive, and it uses this reg open key ex. So we can actually check this one here. What this 80001? What H key is that? So let's Google that one. How many zeros is that? One, two, three, 4, 5, 6. Okay. So it here we have. So this is actually a constant for a particular registry. Um, so because when we open this one here, the reg open key, let's Google that one as well, just to have an idea what it does. So the parameter here is the all of these pushes are the parameters. So that's PHK result, this sum desired, UL options, the sub key, and the H key. So when you check it there, this is actually reversed here. So this is the first push, the second push, the third push, the fourth push, and the fifth push. So it's kind of reversed when you check it here in the assembly. So just checking the H key. This is the H key here. So according to this, H key is a handle to an open registry key. This handle is returned by the reg create key ex or reg open key ex function, or it can be one of the following predefined keys: H key class root, H key current config, H key current user, H key local machine, and H key users. So as we can see here, there's a constant here, the 80000001. So this is actually H key current user. So we're just going to put a comment in it. So how do I do that? Let's check what this does here. Oh, here we go. Let's see if we can find an H key. Here we go. So I'm just going to. There you go. So Sam desired. I don't really know what it is. I'll check what it is here. Sam desired. So according to this, this is a mask that specified as desired access rights to the key to be opened. The function fails if the security descriptor of the key does not permit the requested access for the calling processes. So that's not really. Um, Let me see. So that one there is F03F, so key all access. So we're just going to use another. There we go. So, all right. So it just opens this registry hive, the HKey user, current user, and software Microsoft Windows current version run. It opens that one. So if it's successful, it will go to this green arrow, and it will set uh, a registry, which we don't know yet. So this should be on the. Okay. So we don't really know yet what's the set value, but here the LP value name is being uh, is part of the parameter of this function. So I don't know what it does yet. What what's what value it register there. So what? But we know that this is a persistence key. So we know that it already has a persistence mechanism, and it closes after it sets the registry. So let's go back to the import table, and because we had a hint now what this function does, we can actually rename this function name and just rename it as uh, persistence. Create persistence. So we have renamed that one, and it also show up here. There you go. So let's find another one. So there's a get adapter info here. It's also quite interesting. Let's check one there. Um, okay. So nothing really. So it's okay. So it tries to get the the adapter info, and this is the format here. You can Google that one. So yeah, it's just getting the MAC address and prints out on with this string format, here. So I'm just going to rename this uh, function as get MAC address. So let's find another one. Here's a copy file. So this is also very interesting. So we're going to check that one as well. Hmm. What does this do? Okay, so there are copy file call here, but let's see what if we could find an oh code. Okay, so there's a file folder. E- um, this is a file name. So which one is this going? Let's find the cross reference for this. Nothing. Push. Okay, this is a constructor here. Very long string allocator. Tries to, what's this one? So it looks like tries to copy this file here. I'll assume that it's copying this file here to somewhere. This file. So I'm just going to rename this part here. Drop something. Okay. So let's find another API call. Interesting API call. So what we all do right now is just assuming first. Um, so it has a call here, and I'll just going to rename this for this part. Rename this function as a copy file name exe. Okay. Um, let's find another one here. Just copy file A here. Let's check what it does here. Uh, okay. So there's a copy as well there. So there's a create persistence. This is what we created, renamed a while ago. Yeah. So this is probably the main function here of the malware. So to make this easier, I would decompile this file. This is a pretty big function. It's really hard to grasp um, when we manually analyze this assembly. So there's a tool, there's a plugin for IdaPro that you could decompile this one. So you can open view, open subviews, and generate pseudocode. And it's now being decompiled. So it's much more easier to analyze the file. So there are shell executes over here. There's another one there. So copy file A. See. So string over here. You can actually make that more beautiful by checking that one. Analysis option. Print only constants with literals. Let's try that. Oops, not. Thing happened. Okay, so it's readable now. So there are standard calls here, cout. So I'm going to just probably rename that to cout as well. It's easier. There's also another standard library call here, constructor allocator for this one, and Just going to rename this URL. So what we're going to do now is just rename the variable names to a more sensible uh, naming. There's a low byte here. What's this one? 1, 2, 1, 3, 1, 4, 1. It's probably a flag. I'm just going to rename it as a flag. But I'm not really sure if it's a flag. I just named it as a flag. So as you rename this, so what? Uh, when we analyze this file, we're just going to rename whatever we can find, and as we rename it, it will just make sense in the long run. So, for example, I encounter this function here, and I open it, and doesn't really make sense for me right now. So there's you can actually convert this to as ASCII character. So right now it doesn't make sense. So we can rename that one. So A1 is the returned value, so it's probably an out. So I'll just make it as a pointer out. And A2. So if equals, oh, I'll just rename this as a counter, I think, or index. A7. Not sure what it is. A2. Let's rename it pcar. I don't know. Yeah, that's probably just rename a string. So this is a counter here, decimal. Why is it 1? So A7 minus 1. So let's go back there. That doesn't make sense for me right now. So V41. What's that one? V34. So this is the app folder. Oh, okay. So this sh get folder path A, we can actually Google that one and check what's the parameter. So the parameter is handle window, the CSIDL, H token, DW flags, and PSICE path. So the thing that we need to check is the CSIDL. So the CSIDL value that identifies the folder whose path is to be retrieved. Only real folder are valid. If a virtual folder is specified, this function fails. You can force creation of folders by combining the folder CSIDL with CSIDL flag create. So CSIDL is this one. So this one is a constant here. We need a we need the we have a 26 decimal probably, or 1A hex. So what we don't know that yet. So I'll just going to Google CSIDL 1A. So there are a lot of constants here. So you can see it's an app data 1A here. So we can actually just find the constants here using enum, and from that you can click OK and just find app data. CSIDL. There you go. So this just gets the path of the app data path. So I just rename that as app data path. And this one here, I'm just going to rename this. So yeah, this is going to take a long time. So I'm just going to fast track here. So there are several calls here. There's a copy file, shall execute. It's probably trying to drop a file here. Let's check what this one does. Okay, so it reads something and opens a file which we don't know yet. So I'm just going to rename that as get file name, something like that, or open file. Then let's check what this does. One, just get module file name. I'm just going to rename that as get module file name. So that's your module file name. So let's see what's v24. So copy file A is the parameter is the first one is the LP existing file name, or the source, and the second parameter is LP_CSTR LP new file name, or the destination, and the third one is a boolean B fail if exist. So this is source and this is destination. So your source is your module file name. So it just copies the file to this destination here, which we don't know yet. Wait. So this is the destination. Sorry, this is the destination here. So the source path would be the LP file name. Where does it go? Okay, so it tries to open this one. If T8, this is a global variable. I'm just going to rename this as a global variable. So is this with less than 10? Source. Ah, am I right? Existing. Ah, I'm wrong. So this is the source. This is the destination. Okay. So the source is your module file name. So it copies this file. So it just gets the file, the path of this executable file. And so the destination file would be the LP new file name, which I don't know yet what it does here. How did, wait, destination. Not sure how it got that. We see the disassembly. To get module file name, cx. So I don't really get it now how it is, how was the destination. But I'm going to go back to that one later on and just find the other um, interesting stuff here. So it also creates persistence. So this is the one that we've created, analyzed a while ago. Just going to check out. So check that one here. So another one here, it tries to connect to Wikipedia.org. So it tries to delete the URL cache entry for this URL domain and downloads um, uh, this website here, enwikipedia.org, and save it as scpp-logo 285728. So let's check what's, just to be sure. So the first call is the p caller, and the second one is this the SZ URL. The second one is a Z file name. So a Z file name is a pointer to a string value containing the name or full path of the file to create for the download. If SZ file name includes a path, the target directory must already exist. Okay, so it just downloads this wikipedia.org and save as cpp log dot dash logo 285728 test, in the directory where this malware resides, and it sleeps. Let's see. So it sleeps for, this is milliseconds, I think. So yeah, this is milliseconds. So this is 1 second. So what it does is it just loops for 1 second until it successfully connects to wikipedia.org. Okay. Just check for internet connectivity. So I'll just rename this a check internet connectivity. Okay. Let's go back. And what's this one here? Okay, another interesting. Oh, what's happening here? Ah, yeah. Okay. Just want to rename this. Ah, okay. So it downloads something here. There's the download URL. And what's this one here? V12. This is interesting stuff here. Okay, I'll just going to rename that first because there's a lot of confusing constructor there. Just going to rename it as download dl dot dl dot. What's the file name again? Win win test dl version. Okay, just going to rename the download win test. Okay, let's go back. Oh, okay. So it tries to execute this one here. V63. Yeah, V32. Okay, so it tries to execute this after it downloads that one. So it attempts to execute the downloaded file. So how does it? Let's check what's calling this function. This is probably the main function of the file of the malware. Let's check what's calling this. Okay, so it's a callback function. So yeah, okay, this is a Windows class. Okay, so what it does, this is we are in the Win main right now. So in the Win main, once the malware is being executed, this should be the main function of the malware malicious code. So what it does, it creates a window with this icon here. This is a kernel, it's probably a kernel 32 icon, and the class name would be the class. Well, the class name is class name, and it registers that Windows class with this callback function. So I guess going to rename that a callback function. So once it's been registered, it can it will create that window with this handle, and once it creates that window, it will call this callback function, and it will execute the malware. Let's see. Okay, it's just get message. Yeah. So once it calls this create window exw, it will um, a message will be sent to this callback function. So let's check. So this one here is the callback function. Just going to refresh this one. And your message is let's just see. So your message is equals to 1. So let's find a constant for that one. Let's check. So 001 is WM create. So I'll just rename that to WM create. So once the window is created, it will proceed to the to this routine here. So it just this one just this is just a standard out C out string. This one allocates this string here to this. So this is probably the download link at the download URL, which will one this one will be used for later on. There's another one here as a create thread. So let's follow this create thread here. So it this let's see what create thread parameter are. So create thread has this parameter. Um, the one that we will be interested is the LP start address, because this will be the callback function, which this is a function that the thread will execute. So this one here. So let's go in there, and there's just a forever loop. And there's a sleep as well here. Just sleeps for 6,000 milliseconds or 6 seconds. And just loops and calls this function. Let's see what it does. Check this one. So okay, so get drive type A. Let's check the MSSD and what it does. So determines whether this is removable, fixed, or CD-ROM. RAM disk or network drive. So what's the LP? What's the return value? Okay, so 2 is a removable drive. So it checks for if the path is a removable drive. Drive removable. Okay. Let's see if this is a character. What's this one? There's a counter over here. Okay. So it just this is one just enumerates the removable drive. Okay, until Z. Mm. So it's just a loop. Drive letters from C to Z. Okay, let's go back. I'll just rename this as uh, loop loop drive letter. Oh, okay. So this is probably the worm functionality. It copies a copy of itself to the removable drive, and yeah, so it copies this itself as new file, a new folder.exe to the removable drive. So it just loops it. So I'll just going to rename this as infect removable drive. And rename it again. So we have now an idea of what the file does, what the malware does. So it has a thread for the worm routine. It just copies itself to the app folder. Yeah. So I'll go into just this is just a guess for me right now. We will going to execute this file later on and just um, we will confirm what this file does. So if the it creates some windows. So let's go back here and the main function. So in the main function, it creates a window, invisible window, um, and this is the callback function here. So once it calls this create window exw API, this callback function will be loaded. Um, so once it's inside the in this inside this function, if it is a create window, so let's check it out again. So when sent when an application request with that a window be created by the call by calling the create window ex or function create windows function. So this will be true because it has been created using create window function, create window ex function. So it tries to look for the app data folder first, then yeah, I just skip this part here because it's very confusing for me right now. And it opens itself and copy the file to this destination here and executes it. It also creates a persistence. Uh, creates this registry hive. What else do we see here? After it creates a persistence, it checks for internet connectivity through wikipedia.org. And afterwards, it downloads a file. Then afterwards, it executes that file being downloaded and just finished. So basically, it has three major functions. It drops a copy of itself to app data. Then, uh, yeah, this is the part here that and executes itself from app data folder. Then it creates a persistence. There's another one here that we missed the create thread. Where is it? There we go. And there's also has a thread that um, infects the removable drive every 6 seconds, and also downloads another file from the internet and execute it. So okay, so we have now a very clear indication of what this file does. So later on, we will go into execute this file and check uh, and check and just let's confirm um, what this file does. This sample does. Okay. Uh, we'll have a part 3 of this.